Hi friends, today we are going to discuss TCA cycle. This is very important long answer question in the biochemistry chapter, especially in the central metabolic chapter. And we can ask so many multiple choice questions from this chapter. This is beyond the examination purpose. The TCA cycle will provide energy to our body around 50 to 70% of the energy. So that's why this is a TCA cycle is very important to know the reaction, and this is not only for the energy production, because the TCA cycle intermediates will participate in so many reactions. The TCA cycle is also known as Krebs cycle, citric acid or citric acid cycle, TCA cycle, Amphibolic cycle, final common pathway, central cycle. These are the other names of TCA cycle. So the TCA cycle, the first product of TCA cycle, that is called as first product. Hence it is called as citric acid cycle. And the citric acid contain 3 carboxylic group in the structure. Hence name is called as tricarboxylic acid. Amphibolic means it is contain both unit, anabolism plus catabolism. So hence it is called as amphibolic cycle. And why it is called as final common pathway? Because carbohydrates, amino acids, fats finally produce acetyl-CoA. Finally commonly produce acetyl-CoA. Now this is enter one pathway. So that pathway name is called as TCA cycle. That is called as final common pathway. So that is TCA cycle. The TCA cycle location, this takes place in mitochondrial matrix. It is near to the electron transport chain. So this is the site of the reactions. Okay, now we will see in detail what is a TCA cycle. The TCA cycle simply known as observe carefully is key to success by secure first mark. So this is a TCA cycle. Okay. Finally, I am going to ask you the same questions. Okay, what I written here. Okay, Muna, listen carefully. Okay, observe carefully is key to success by secure first mark. Okay, this is called as TCA cycle. Okay, we'll see you later. The Krebs is a scientist name who invented these reactions. Okay, after preparing this research work, his manuscript submitted to the Nature journal. The Nature journal simply rejected his work, and later Krebs is submitted to Enzymology, another journal, then published successfully. Then finally he got a Nobel Prize for this work. Okay, so that's why initially you may get insultation from anyone. Okay, finally, if you are confident with your work, you will be success. Is a very good example. And just store in your mind, today is the first day of your remain life. Clear? So don't think about past. Past is past. Okay. Now we'll see. The first one is you know what is the aerobic glycolysis end product, that is called as pyruvate. The pyruvate only is going to convert it into acetyl-CoA. Acetyl-CoA. Clear? By the enzymes called as PDH complex enzyme. PDH complex enzyme means it is contain 3 enzymes. Okay, 5 coenzyme. Enzyme 1, enzyme first enzyme PDH. Okay, like 3 enzymes plus 5 coenzymes. The 5 coenzyme name is called as TPP, NAD, FAD, lipomide, and coenzyme A. So the 5 coenzymes are very important, and the 3 enzymes are very important. Then only the pyruvate is converted into acetyl-CoA. Clear? This is, in a short way, I am going to explain you. Okay, how pyruvate. The pyruvate means it is made up of the 3 carbon atom. The 3 carbon atom of pyruvate react the same enzymes, but I will explain in very short methods. Okay. Just carbon dioxide released from the carboxyl group. Remaining series one hydrogen atom. This hydrogen atom, okay, taken by NAD. NAD is converted to NADH. Okay, remaining are okay CH3, CO, S CoA, CH3, CO, and S CoA. So this is called as acetyl-CoA. Actually, this is very shortcut method. Okay, if I am have to explain means I already explained to you. Okay, how the pyruvate is converted into acetyl-CoA by using 3 enzymes plus 5 coenzymes. Clear? Finally, you can get acetyl-CoA. Clear? Now I am going to explain TC cycle. The 2 carbon atom of acetyl-CoA, okay, is a react with acetyl-acetic acid. Now the TC cycle. This is acetyl-CoA. Acetyl-CoA react with TC cycle. Okay, that means first one is oxaloacetic acid. Now the oxaloacetic acid react with 2 carbon atom of acetyl-CoA. Both are getting condensed to form by the enzymes called as citrate synthase enzyme. Clear? Here is water means OH, H. One hydrogen atom attached with hydrogen atom, SCoA, It releases the CoA sketch. Remaining OH group attach here. Then it forms COOH. COOH. This hydrogen, one hydrogen is given to here. Then it forms CH2. Okay. Then CO is converted into OH. Then COOH. CH2. COOH. So this is called as citric acid. Okay. The 2 carbon atom of acetyl-CoA react with 4 carbon atom of oxaloacetic acid to form 6 carbon atom of citric acid. Citric acid. The citric acid is contained, okay, how many carboxyl group? 1, 2, 3. Hence the name is called as tricarboxylic acid cycle. Clear? Now the citric acid is react with aconitase enzyme, removal of water molecule. Then the structure is converted into clear. Here one OH group, here one hydrogen atom released as a water molecule. Okay, this is compound is called as cis-aconitate. Clear. Now the cis-aconitate again react with the water molecule by the same enzyme, that is called as aconitase enzyme. Okay, then it forms this is called as isocitrate. Okay, now you may ask why water molecule is going outside, why water molecule is coming inside, to changing the structure. Clear. So now the citric acid is converted into isocitrate. Okay, for that purpose only. Okay, you may think I can hear your mind voice. Why the cotton bags? Let it be in the warehouse. No, not like that. Actually, this is citric acid. The citric acid is converted to isocitrate. Iso means the same molecular formula but different in the structure. But here is the third carbon atom contain OH group. That means tertiary alcohol. Tertiary alcohol is very far from the functional group. Clear. So that is why then citric acid is converted into isocitrate. Now the isocitrate alcohol groups is present in the alpha position. Previously in beta position. Clear. Previously in beta position of alcohol, that is called as tertiary alcohol. The third carbon atom contain alcohol. But here is second carbon atom contain alcohol. In the secondary alcohol, very easy to get oxidation. That is the purpose. Citric acid is converted into isocitrate. Clear. Now the isocitrate is contain secondary alcohol, very easy to get oxidation. Okay, by the enzymes called as alpha keta glutarate dehydrogenase enzyme. Here is NAD is converted into NADH. At the same time, carbon dioxide also released by the enzymes called as so this is isocitrate dehydrogenase enzyme. Isocitrate dehydrogenase enzyme. Clear. Now after removal of water, NADH and carbon dioxide, then it forms CH2, CO, COOH. This is functional group. This carbon is called as alpha carbon. So alpha carbon contain alpha is contain ketone group. Alpha keto. The overall structure is called as glutarate structure. Clear, Umar? Listen carefully. Okay. So this is how it is removed. The carbon dioxide removed from here. Okay. Then NADH taken one hydrogen atom. That's why it forms ketone group. This is called as alpha keto glutarate. Now the alpha ketoglutarate again undergo oxidation by the enzymes called as alpha ketoglutarate dehydrogenase enzyme. Clear? NAD is converted into NADH. Clear? Here is CoA SH is involved. Simultaneously carbon dioxide also removed. Now it forms this is called as succinyl-CoA. This is called as succinyl-CoA. Actually, this enzyme alpha ketoglutarate dehydrogenase enzyme also is completely resemble like a PDH enzyme. This is also required. Okay, 3 enzymes. Okay, 5 coenzymes. Okay, clear. Now see here, the carbon dioxide is released. Here is one hydrogen atom. Here is one hydrogen atom released as a NADH. Okay, the remaining are COH, COH, CH2, CH2, CO, only CO attached with the S-CoA. Clear? This is called as succinyl-CoA. Now this succinyl-CoA is converted into succinic acid by the enzymes called as succinate thiokinase enzyme. This is very important steps. Here is they will ask very important multiple choice questions. Okay. This step is the coenzyme. Here is 1 GDP react with the inorganic phosphate to form GDP. Then it forms succinic acid. You know water molecule means? Okay. OH, H. One hydrogen atom attached to the S-CoA. This is the CoA SH. Okay, remaining OH attached to the CO to form COH. This is called as succinic acid. Okay, listen here. What is the important MCQs here? Here is substrate level phosphorylation is produced between the 2 S. Okay, succinyl-CoA and succinic acid. Between the 2 S, one more S is there, that is called as substrate level phosphorylation. Clear? Between the 2 S, substrate level is phosphorylation. Between the 2 S, one more S. This S is explained by one more S, that is Dr. Salim. Okay, now see here, the succinic acid again undergo oxidation by the enzymes called as succinate dehydrogenase enzyme. But here is flower protein is involved. How to remember the flower protein here? Okay, I will explain you. This is fumaric acid. If you are writing fumarate here, so you can remember this enzyme F for F. Clear? So the fumarate is produced. That means you taken one hydrogen atom from here. So it forms FADH2, okay, and fumarate. Now the fumarate react with the water molecule by the enzymes called as fumarase enzyme. By the enzymes called as fumarase enzyme bring in the water molecule. Okay, the water molecules means you know OH, H. Clear? One OH attach here, one hydrogen atom attach here. Then it forms COH, CH, OH. One OH attach here, one more hydrogen atom attached here. Then it forms. Okay, this is called as malate or malic acid. Clear? Now the malate again undergo oxidations by the enzymes called as malate dehydrogenase enzyme. Malate dehydrogenase enzyme getting oxidations. Okay, malate getting oxidation by the malate dehydrogenase enzyme. Here is one hydrogen atom. Here is one hydrogen released as an adduct. Then COH, COH, CO, CO, CH2, CH2, COH, COH. So again back to form oxaloacetic acid. That is called as cyclic process. Hence it is called as TCA cycle. Clear? So this is very simple reactions. Clear? Are you understand now? Okay. Now we will see how many NADH is produced. We are going to calculate energetics. Okay. Totally 3 NADH. One NADH enter into electron transport chain. It can produce 2.5 ATP. 3 NADH means, so totally you can get 7.5 ATP. Okay. One FADH2 enter into electron transport chain. Then it can produce 1.5 ATP. Clear? And substrate level phosphorylation. Substrate level phosphorylation is produced GTP. 1 GTP is equal to 1 ATP. 1 GTP is equal to 1 ATP. So totally 10 ATPs are produced per acetyl-CoA. One acetyl-CoA enter into TCA cycle, then it can produce 10 acetyl-CoA. This is energetics. Clear? Now I already told to you, initially observe carefully is key to success. By secure first mark. Okay, that means O. O stands for oxaloacetic acid. C stands for citric acid. Is stands for isocitrate. Isocitrate. Clear? K stands for ketaglutarate. S stands for succinyl-CoA. One more S stands for succinic acid. F stands for fumarate. M stands for malate. So this is very easy to remember. Okay, here one more also is required. This cis-acetonate is not that much very important because only one enzyme. Clear? Okay, for your understanding purpose only. Okay, I am writing the cis-acetonate. Then only you are able to understand how the tertiary alcohol is converted into secondary alcohol. Clear? Now, isocitrate directly do not change into alpha ketaglutarate. It is changed into another form. Okay, that is oxalosuccinate. That is not important because the same enzyme, isocitrate dehydrogenase enzyme, is going to involve. So that's why directly I removed the carbon dioxide here itself. Clear? Okay, so this is a very important steps. Don't forget anything. Okay, this is very important enzymes and the steps, how many ATPs also produced. Okay, you got some idea. Now we are going to explain. Okay, what is the inhibitory? What is the inhibitor? The inhibitors of TCA cycle is for easy to remember. Okay, I am explaining you. Fat, arc, mass. Fat pronunciation. Listen, fat, arc, mass. That means F means fluoroacetate. Fluoroacetate will inhibit aconitase enzyme. Aconitase enzyme. Clear? I'll write aconitase enzyme. Okay. Arsenate. Arsenate will inhibit ketaglutarate dehydrogenase enzyme. Clear? Malonate will inhibit succinyl dehydrogenase enzyme. Clear? Fluoroacetate inhibit aconitase enzyme. Arsenate will inhibit ketaglutarate dehydrogenase enzyme. Malonate inhibit succinate dehydrogenase enzyme. Clear? Now we are going to discuss regulations of TCA cycle. What is a regulation? Regulation of TCA cycle. The first condition, okay, it is required of more amount of ATP. More amount of ADP. ADP only will stimulate this TCA cycle reactions. Clear? So this is very important. Okay. Then citrate synthase enzyme. The first enzyme, citrate synthase enzyme, isocitrate dehydrogenase enzyme, isocitrate dehydrogenase enzyme, and alpha ketoglutarate dehydrogenase enzyme. The three enzymes are very important regulatory enzymes. Allosteric regulation. Allosteric regulation. Clear? So this is very important. Okay, all these four are very important to regulation of the TCA cycle. Okay, and if it is more amount of ATP or more amount of NADH, these two things always inhibit the TCA cycle. So that is very important regulations of TCA cycle. Clear? Now we will see what is the meaning of catabolic reaction. I mean amphibolic reaction. Amphibolic. I already told you amphibolic. Amphibolic means it is contain both reaction, catabolism plus anabolism. What is the meaning of catabolism? The catabolism reactions, the acetyl-CoA break down into two carbon dioxide. This break down into two molecules of the carbon dioxide. So that is called completely breakdown. That is catabolism reaction. Anabolism reaction. Anabolism reaction means, okay, the oxaloacetic acid, the citrate, alpha ketoglutarate, and the acetyl-CoA. These are not only for the ATP production, at the same time this will be involved some other reaction. Okay, whenever there is aspartic acid is less, so aspartic acid can be synthesized from oxaloacetic acid, which is useful for purine production, purine formation. Clear? Now citrate. The citrate, it is present in mitochondria. Okay, clear? The mitochondria, it is going out to the cytoplasm. It is moved to cytoplasm. Move to cytoplasm. Then after going to the cytoplasm, then it can produce acetyl-CoA. This acetyl-CoA, which is useful to produce fatty acid, steroid, cholesterol. Because acetyl-CoA is present inside of the mitochondria. So acetyl-CoA cannot go outside. Acetyl-CoA can go in the form of citrate. The citrate only can go out from mitochondria to cytosol. Clear? By the shuttle system, that is called a citrate shuttle system, it can go outside. So then only it can produce fatty acid synthesis, steroid possible, and cholesterol synthesis also possible. Clear? Now alpha ketoglutarate. Alpha ketoglutarate, which is very useful to synthesis of glutamate. Glutamate. Clear? And then it can be very useful to synthesis of GABA. Okay. Now the succinyl-CoA, this is very important compound to produce heme. How it is produced heme? This succinyl-CoA attach with the glycine amino acids to form ALA, delta amino levulinic acid. It's a precursor to synthesis of phosphorylate. Finally, it can be produced hemoglobin. Clear? And the succinyl-CoA, which is very useful to break the ketone bodies, to break the ketone bodies. That is called as ketolysis. Okay, I think you know that step. This is required thioporase enzyme. The thioporase enzyme, which is not available in the liver. So that is why the ketone bodies cannot be used by liver. Clear? So in this step, succinyl-CoA is very important. Then only it forms acetyl-CoA. The ketone bodies are getting breakdown to form acetyl-CoA. Clear? So the succinyl-CoA is very important to synthesis of hemoglobin, very important for synthesis of acetyl-CoA. Clear? So this is called as anabolism reaction. Now finally, explain refilling. Refilling is called as Anaplerotic reaction. Anaplerotic reaction. Okay, so Anaplerotic reaction means otherwise called as refilling. Suppose oxaloacetic acid, if it is not available, if it is participating some other reaction, the oxaloacetic acid should be available here. Clear? Oxaloacetic acid. Okay. Alpha ketoglutarate, succinyl-CoA, fumarate, malate. This is refilled by, suppose oxaloacetic acid not available. Suddenly the pyruvate is undergo ABC reaction. Okay, ATP, biotin, carbon dioxide. That enzyme is called as carboxylase enzyme. Carboxylase enzyme. Then pyruvate can be converted into oxaloacetic acids. Clear? Suppose alpha ketoglutarate is not available. Suddenly the arginine amino acid, proline amino acid, histidine amino acids, and glutamate can convert it into alpha ketoglutarate. Clear? Suppose succinyl is not available here. Immediately propenyl-CoA converted into succinyl-CoA. And some amino acid also. Threonine amino acid, valine amino acid, isoleucine amino acids, methionine amino acids can convert it into succinyl-CoA immediately. Clear? Here is fumarate is not available here. Suddenly phenylalanine amino acids, tyrosine amino acid, or else urea cycle can provide fumarate. Suppose malate is not available here. Suddenly pyruvate undergo malic enzyme to form malate. So in that way it will be refilled. That is called as anaplerotic reactions. Clear? So this is called as TCA cycle. So the TCA cycle, all the steps is very important. All the enzymes are very important. How many energetics are is very important. Okay, how it is inhibited? Inhibited by some chemicals. That is called as very easy to remember. Okay, FAC I told. FAC, ARC, and MAS. Okay, this is called as fluoroacetate. Always inhibit aconitase enzyme. Arsenate chemical will inhibit ketoglutarate dehydrogenase enzymes. Malonate is inhibit succinic acid dehydrogenase enzyme. Succinate dehydrogenase enzyme will be inhibited. So this is called as TCA cycle. You should know the regulations and Amphibolic cycle and Anaplerotic reaction. So this is TCA cycle. Okay, bye.